Okay, the next part. For each pair of similar figures, find the ratio of the area of the first figure to the area of the second. So the similarity ratio is 8 to 12, but I want to reduce that. So I divide both sides by 4, so it's 2 to 3. So that means the area ratio is 2 squared to 3 squared, so the area ratio is 4 to 9. I would simplify first before I squared it. It just makes it easier to simplify. This one, the similarity ratio is 6 to 4. I simplify it, it's 3 to 2. Then I square it, so it's going to be 9 to 4. And then number 17 is 3 to 6. I simplify it to 1 to 2, and then I square it to 1 to 4. And number 18, the ratio of the areas is 8 to 25. What is the ratio of the perimeters? So these are squared terms, so to figure out the perimeter ratio or similarity ratio, I need to take the square root of both of them. So this is going to be 2 root 2 to 5, because if I break down the square root of 8, it's 2 root 2. And then number 19, find the area of a regular decagon. So I'm going to do this one down here with radius 5. So I don't need to draw a decagon. I need to draw that special triangle in the decagon. So if the radius is 5, then this angle right here is 36 divided by 2. So this angle is 18 degrees. And so I need to do the formula area equals 1/2 apothem times perimeter. So I need to get this side the apothem. We'll call this x. So if I use the trig formula, cosine, because it's adjacent over hypotenuse, I'm going to write the cosine of 18 equals x over 5. So x equals 5 cosine 18. So I have area equals 1/2 the apothem, which is 5 cosine of 18 times the perimeter. So the perimeter, there's going to be 20 of these. So I need to figure out what y is. So y is sine. So y, I'm going to do the sine of 18 equals y over 5. So when I plug this in, it's going to be, the perimeter is going to be 5 sine of 18, but there's going to be 20 of those sides. So I'm going to write 5 sine of 18 times 20. This is my perimeter. So you put that all in your calculator. You get about 73.5. And then 20. I'm just zoom in a little bit. A regular pentagon with a apothem of 8. So again, I'm not going to draw the big triangle or the pentagon, but I know this is 8. And I know this angle is 360 divided by 5 divided by 2. So it's going to be 36. And you need to figure out what x is to get what the perimeter is. So I do the formula, area equals 1/2 AP. Area equals 1/2 the apothem, which is 8, times the perimeter. So the perimeter, I need to figure out what x is. So I'm going to use tangent because I have opposite over adjacent. So I do the tangent of 36 equals x over 8. X equals 8 tangent 36. Now if it's a pentagon, there's going to be 10 of these. So I do times 10 times 8 tangent 36. and that is about 232.5 centimeters squared. Okay, then 21 is a regular hexagon with a pathum of 6. So I'm going to make some room way in this corner. So a regular hexagon with a pathum of equal to 6. So a hexagon, this angle is going to be 30. So this is going to be 6 divided by root 3. If I set up my special right triangles. So if I rationalize it, it's going to be 6 root 3 over 3, which is 2 root 3. So when I do my area is 1/2 AP. Area equals 1/2 the apothum, which is 6. The perimeter, if this is 2 root 3, we're going to have 12 of these. So it's going to be 12 times 2 root 3. So the area is approximately equal to 124.7 inches squared. And I'm going to skip 22. I feel like we're getting redundant here. Okay, 23. If you're going to find the area of this type of triangle, we don't have a right angle listed, so we can't use, we don't have a right angle, so we don't really know what the base and what the height is. We're not sure that this is a right angle. We have an angle that's between two sides. Okay, so when you know the angle, and you know the two sides that include the angle, you can use the formula area equals 1/2 BC sine of A. So this is area equals 1/2 15 times 19 times sine of 45. So when you put that in your calculator, it's about 108 centimeters squared. Same with 24, you have an angle and you have the two sides that include it. Angle and two sides. So you do area equals 1/2 BC sine of A. So it's 1/2 times 15 times 13 times sine of 65. So that is 88.4. And then the next one, it's similar. I'm not going to go through the work on it, but it is 70.4 meters squared.